CCI, Crash Course Instrumentation, presents Saturday, Tuesday, Specials. Episode number 15, The Centrifugal Pump, from Papin to Appold to today. Hook, the spinning wheel that moved cities. What single machine moved floodwater off farms, pressurized city mains, and made modern process plants possible? The centrifugal pump, a spinning impeller that turns rotation into a steady push of liquid. What you will learn today. Where the idea came from, the math breakthrough that explained it, the design change that made it practical, and why these pumps still dominate anywhere low-viscosity liquids need to move. Early spark, Papin's idea, late 1600s. Denis Papin sketched a pump with straight radial vanes that flung water outward by centrifugal action. It proved the concept, but efficiency was limited, and the casting quality of the day held it back. Math catches up. Euler, 1700s. Leonhard Euler described how rotating machines add energy to a fluid. In plain English, blade shape and speed set how much head a pump can build. Engineers finally had rules to design, not just tinker. First practical builds, early 1800s. As iron foundries improved, builders created compact pumps for mines, drainage, and mills. Simple, rugged, easy to maintain. The centrifugal pump began replacing big, clunky reciprocating machines for many water duties. The leap, Appold's curved vanes, 1851. John Appold unveiled a curved-vane impeller that slashed shock losses and lifted efficiency dramatically at London's Great Exhibition. Curved vanes turned the idea into an industrial workhorse. From mills to municipalities, late 1800s. Makers standardized casings, impeller patterns, and shaft seals. City waterworks and factories adopted centrifugal pumps for reliable, smooth flow with fewer moving parts. Modern refinements, 1900s today. Better materials resist corrosion and abrasion. Mechanical seals replaced packing for cleaner, safer service. Multi-stage designs reach higher heads. Today, computational fluid dynamics shapes impellers before a single casting is poured, and variable frequency drives let one pump cover wide operating ranges. Quick demo you can picture. Imagine a clear bowl with a small impeller. With straight vanes, the flow exits with a lot of swirl and waste. Curve the vanes, and that same spin produces smoother, higher pressure flow. You can see why Appold's change matters. Why centrifugal pumps win. Simple mechanics, continuous flow, easy to scale, and tolerant of a little grit or bubbles. For clean or lightly dirty liquids, they beat reciprocating complexity most of the time. Limits to remember: very viscous fluids? Go positive displacement. Need precise small flows regardless of back pressure? PD again. But for water, chemicals, and utilities, centrifugal is king. Takeaway. 3 moments built the modern pump. Papin's concept, Euler's explanation, and Appold's efficiency. Everything since is refinement, and that is why these pumps are everywhere. Wrap up. Next time you hear a cooling tower whoosh or see a fire pump test stream, you are listening to 3 centuries of iteration. Thanks. Huge thanks to Tony Kirpalt and the open source community for the outstanding free curriculum that powers Crash Course Instrumentation.